Hello, this video has been created for the purposes of the Design4Energy training workshop, and this video deals with a retrofitting workflow developed as part of Work Package 5. To improve consistency of construction information related to building energy analysis, building information modeling can play a key role. Building information modeling enables a collaborative way of working and better informs decision-making processes from the early design stage through to maintenance. By employing rapid energy analysis, the potential of building information modeling in informing low-energy strategies of buildings is highlighted. This is a fact recognized by the building analysis community in the design stage of buildings. In the post-occupancy stage, a systematic methodology that would ensure that the building's thermal behavior is monitored and the findings are incorporated in the decision-making process is still missing. The main challenges include the lack of BIM of older buildings, the need to determine the minimum data requirement for the creation of BIM, and the incorporation of real-world measured data into the modeling process. Focusing on retrofitting is important. Statistics to support that are provided. Currently, a substantial share of the stock in Europe is older than 50 years, and about 90% of the existing building stock will still be in use by 2050. At the same time, the current average energy consumption needs to be reduced by a factor of 4 or 5, and the Energy Performance of Buildings Directive Impact Assessment concluded that the potential for cost-effective energy savings in the EU building stock is about 30% in the period to 2020. Currently, the process starts with the BIM model development. Autodesk's Revit is being used. Even when using the most popular formats for data extraction from BIM, the user has limited knowledge of the data contained in the files. Intermediate software enabling the use of BIM to proceed with energy analysis, such as OpenStudio Design Builder, can be used to facilitate the process. To cope with the missing data, default settings are used regarding thermal characteristics of the building envelope and systems and occupant behaviors. In many cases, the user has limited control over the default settings used. Often BIM for sustainable design of existing buildings relies on estimated values for some of the building's thermal characteristics, such as loads, schedules, and airflows. As retrofit decision-making in buildings is not supported by real-life data, the accuracy of the retrofit analysis is limited. The Design4Energy retrofit goals include the development of a decision support tool able to automatically generate different scenarios for optimized design for retrofitting and refined through engagement with the various stakeholders. The retrofit workflow starts by conducting a building survey to collect information including the building location, orientation, geometry, plans, and construction details. In addition, operational data from the building while in use are needed to enable a decision to be made on the need for retrofitting. Once the decision to proceed with retrofitting of the building under study has been made, the BIM model needs to be developed. To support the development of the Revit model, a user guide has been developed, providing guidance on good practice when designing in BIM, in Revit, with the energy analysis in mind. A series of tools developed bridges the gap between BIM and BEM: the editing tool, the options generator, the conversion tool, the Energy Plus runner, the Energy Plus KPI tool, and finally, the retrofit decision support tool. Although the workflow has been designed with retrofitting in mind, it can also be used for the conceptual level of new builds by skipping the step of conducting building survey to collect the necessary data. Instead, the architect's and client's preferences are taken into consideration. The good GPXML export guidelines have already been presented in another video created for the same purpose of the training workshop. It consists of 20 points, and in this video you can see a step-by-step guide using the Revit user environment. Although any BIM software is able to incorporate a great number of information on all aspects of the building as a project, there is certain information required for energy modeling that is not included in BIM. A tool has been developed, the GPXML editing tool, which is able to edit the GPXML file in order to integrate some additional information that have been collected at the building survey and operational data collection stage. The output of the tool is the GPXML file for the base case building, complete with all the information required to proceed with energy analysis. The output of the editing tool was called the base case building, as this model can be used by the options generator tool, a tool linked to the Design4Energy component database to generate a number of GPXML retrofit alternatives, each representing a retrofit option for the building under study. After the base case GPXML and alternative models have been created, the next step is to create energy models and proceed with energy analysis. The selected energy modeling software is the well-established free, open source and cross-platform Energy Plus. The building representation for Energy Plus is contained in an IDF file format. Therefore, a GPXML to IDF conversion tool has been created to allow for controllable information exchange and transparent default setting. A IDF XML template file is being used to enable the mapping of the data from GPXML to IDF. The template provides links to the necessary building information so that these can be retrieved from the base case GPXML file and states all of the energy modeling software default settings. A report has been written with all the relevant instructions for the conversion process and can be found in the publicly available deliverable 5.3. Once the conversion process is complete, the resulting IDF file can be used to perform energy analysis for the building. Now we see Energy Plus running, and to the left we can see the output files of Energy Plus. Each run on my computer takes approximately 30 seconds. One of the outputs of Energy Plus is a CSV file containing the results of the analysis on a half-hourly time step. These results are used in conjunction with the relevant GPXML file or a reduced XML file for the calculation of the key performance indicators using the Energy Plus KPI tool. The Energy Plus KPI tool calculates useful metrics indicative of the building's thermal performance to enable comparison with measured data to enhance trust to the modeling assumptions and default set. The output of the Energy Plus KPI tool is the Energy Plus XML file, which can be used to evaluate the modeling results using a dedicated user interface and is also used as the input to the decision-making process for retrofitting. The outputs from the Energy Plus KPI tool serve as the input to the Decision Support tool. Other inputs to the Decision Support tool include the user-defined KPI weights and target benchmarks as set using the Target Setting tool. The Decision Support tool is using a multi-criteria decision-making method called TOPSIS to output a ranking of the retrofit alternatives. So thank you for your attention, and we will be happy to answer any questions you may have.